Hi Jonah, this is your recap video of our lessons on Monday night. Sorry for the delay. Got a lot to get through because we did 2 hours and it was largely me just talking to you and asking obviously a few questions here and there, but you didn't really do any questions yourself, did you? Just be talking about my favourite subjects. So what we looked at was a recap on the rules of indices. I wanted to give you the format for those which I use, so I'll talk about that in a second. Then the reverse of indices, logarithms, and then their rules, and we'll see that they also are the reverse, and you see why I use the format I do. We talked about logs a little bit, where they appear in everyday life, and then that led us to E. We talked about compound interest, how it doesn't matter if you even compound money continuously, it won't grow beyond a certain limit, which is probably a little bit surprising. Next up, we looked at the definition of gradient, and then linked that to tangent, or you did. You said another measure of steepness was angle, and so we looked at that. Then we started on the sine and where that comes from, and then I asked you to think about where do you think cosine comes from, so I'll reveal that in this video. So before we get there, just think about it, maybe make a little note. What is it that you think cosine will be, and see if you're right at the end. First thing I'm going to do is give you some questions to do, just a quick practice, so it's probably worth your while when I go to the next page, just pausing the video, having a go at the answers yourself, at the questions yourself. So here's some indices questions. Pause the video now and have a go. Okay, so the answers. So first one, you should have got 7 to the 5 because multiplication is just addition. First rule of maths, first rule of indices. Second one, 7 cubed because division is subtraction. So there's a power 1 there, so 4 take away 1, 3. And we talked about last night why both those work. Multiplication is addition because of the repeated 7s, and division and subtraction is because the 7s cancel out and it's effectively like they subtract. But there are two general rules in maths anyway we talked about the week before, excuse me, got a bad cold. Last one, next one is 7 to the 0, and you automatically told at school that anything to the 0 is 1, which is true, but we also need to know at A level why that is. And the reason for that was because this was an equal to 1 type of division where it must have been divided by itself. Something's divided by itself, so let's say the previous thing there, 7 cubed, was divided by itself. That was obviously going to be equal to 1. However, in indices terms, we could also write it as 7 to the 0 because 3 take away 3, division and subtraction, is 0. So they're both equivalent things, so anything to the 0 becomes 1 because that thing must have been divided by itself. 7 to the minus 1, talking of reverses, that's going to be the reverse of 7 to the 1. So what's the reverse of a number? It's reciprocal, so it's going to be 1/7. It's also due to division and subtraction, as we talked about. There must be an extra 7 on the bottom that hasn't cancelled, so it's kind of the reverse of the situation where there are more 7s on the bottom instead of the top, and they don't cancel out. So in this case there must be 1 extra, and we know it's 1 extra because it's minus 1. The minus is telling us that the 1 extra is in the division because division is subtraction. So there's a little hint in that. 7 cubed in a bracket, 7 squared in a bracket cubed. Well, as we defined, brackets means multiply, so we just do 2 times 3, 7 to the 6. And next one, 25 to the half, we have the reverse situation. So we have a fractional power, which is the reciprocal. A half is the reciprocal of 2. So 2, if that was a power, would square. So the reciprocal of that does the reverse of squaring. The reverse of squaring is square rooting. So we get square root. Square root of 25 is 5. And finally, the last one is not a typical indices question because it's not saying something to the power of this is what. It's doing the opposite thing, the reverse thing, and saying 10 to the something is 37, so what's that something? So that is where we use logarithms. So the rules for logarithms are just going to be, or what a logarithm is just the reverse of what a power is. So instead of saying 10 squared is 100, it says, what power do I need to make 10 become 100? In this case, what power do I need to make 10 become 37? Now you may recall from Monday, it's 1.568, but that's what a logarithm means. What power do I need to make 10 become? As long as 10 is the base, yeah, so as long as you have 10 down here, that means whatever number down here is going to be. So that number depends on what number down here. What power do I need to make become the next number? So what power do I need to make 10 become 37? 1.568. So that's the notation that we use to solve those problems. But it's just the reverse of a power, that's all. It's just saying, I don't know what the power is, but I do know what the answer is. What could it be? That takes us on to the rules of logarithms. So there again, the reverse of the rules of indices. So first rule of indices, multiplication is addition. So what's the first rule of logs? So again, just pause the video and write down the answers to these questions and check that you can remember what we did on Monday. Okay, so hopefully you've had a go at those. Log 10, whoa, I've not written it right, have I? That's not very fair. Hopefully you noticed that and said, oh Paul, you got that wrong. Log 10 plus log 10, both to the base 10, that's what it should have been, so sorry about that, is addition is multiplication, so that's log of 100. So the rule is exactly the opposite of rule of indices. If I just write over that why that is, it's because log 10 is 1, log 10 is 1, the power I need to make 10 become 10 is 1, isn't it? 1 plus 1 is 2, last time I checked, so log 100 is 2, because 10 squared is 100. The next one, log 1000 minus log 100, that's not log 900, but log 10, because subtraction is division, the complete reverse of the second rule of indices. So 1000 divided by 100 is 10, so it's 10. Numbers wise, it's going to be log of 1000 is 3 to the base 10. Log of 100 is 2. 3 take away 2 is 1, which is what log 10 is. Log 1, like I said on Monday, it's considered to be a rule, but really if you just read it, what power do I need to make 10 become 1? 0. I already know that from the rules of indices, so it's a strange one that. Is it a rule? Do we need to remember it as a rule or just an obvious fact from indices? And then finally, log of 10 cubed to the base 10. Remember, you can bring the power down and it has the same value, and that's because of multiplication and addition. It's everywhere. Log of 10 cubed means a log of 1000, which means log of 10 plus log of 10 plus log of 10, because it's 10 times 10 times 10. And that's 3 lots of log 10, isn't it? So that's why that power can go down there. Okay, so that takes us on to compound interest. I said that we don't really use 10 as a base. It used to be the calculator before yours that you've got at the moment would have had log 10 as a button that you'd always use. But at Casio, I'm pleased to see, I've decided to get with the times a bit and show that mathematically we don't use 10, so that's why it's not there on the calculator, I think. And even some A-level textbooks will get you to use 10. I really don't know why, because we don't use it at all. So if you can avoid using 10, please do. I'll show you how to do that when we're trying to solve problems. It might not even occur to you to use 10 from now on. Hopefully it won't. So 10 is not a number that we actually ever use, unless we're trying to solve a problem involving 10, like like 10 to the x is 37. Well, that involves 10, so I use 10 for that. But if not, I'm not going to use it. What we're going to use instead is a number that fits snugly and nicely into mathematics, which, even though it looks weird as a decimal, is a number that exists in nature, and as a result it fits perfectly, and that number is e. Remember, we found it by trying to continuously compound our savings because it was unfair that we had to wait any time whatsoever, and even when we did that, we found that the maximum we'd ever get to is 2.7 times what we started off with. So another question for you, what is log e to the base e? So a quick pause, what is it? Yeah, it's going to be 1, because what power do I need to make e become e? It's e to the power 1. I had a brief mention of everyday logarithms. I think it's good to see where this kind of thing appears in our everyday life. And luckily you study geography, so I said the Richter scale. And I think it blew your mind a little bit that we actually use mathematics in geography. But the idea behind the Richter scale is that it's 10 times more powerful for every one step you go along. So the difference between the Richter scale of 9 and 10 isn't 1. It's actually 10 times more powerful. So I don't know the numbers, but let's say 9 was 1,000 powerful, then a Richter scale of 10 would be 10,000. So you can see how much more. When they go up the decimals on the news when they say what's a Richter scale of 7.2, you think, oh, okay, that's not too bad. It goes to 8.2, and it's 10 times worse. But it doesn't feel like it when you say 8.2, it just feels like a bit worse. But no, 10 times as violent. That's, that's pretty scary. But because of the way it's written, but I don't think people realise that. Where else? Piano. And the piano, every time you move up 8 notes, or 8 white notes anyway, the frequency doubles. So in this case, it's one step. It multiplies by 2 every time instead of 10 every time, like Richter scale. So there are 2 examples. There's loads more. Yeah, the other one we mentioned was the power of hydrogen, didn't we? So that's why it's called power of hydrogen, because each one I think is 10 times more hydrogen contained. Okay, so that was all logs, E, and indices. So then we moved on to gradient, and you said it's y divided by x, or changing y over changing x. That's true, but what was my definition of it? Can you remember? So just pause the video and think about what it is. Hopefully you remember that it's for every one step you take, it's how many you go up or down. So in this case the gradient would be 1, because I go along 1 and I go up 1. And it's however many you have to go up is the gradient, how steep it is. Okay, and then I've seen you've probably seen I put there another measure of it. So what's another way of measuring steepness? And that way of measuring is with the angle. So that's why I've got that there, which is what you said. Which is great. A lot of people don't realise that, so it's good that you said that. So what we then did was we made a graph comparing angle against the gradient. So as the angle got bigger, what was the gradient? And that's produced the gradient graph, which became familiar to you. I think you realised that it was a tangent graph, or I think you said like it looks a lot like a tangent graph. That's because that's what a tangent graph is. It's a gradient graph. So there you go. So as the angle increases, the gradient increases as well. It reaches infinity at 90 degrees. So that's why the graph goes off all the way up there. Once it passes 90 degrees, the gradient becomes negative. It's now a negative gradient. So as a result, it goes from plus infinity to minus infinity, all the way down there. And as the angle increases further, it rolls round to 180, and it's flat again. And then it just repeats. Another 90 degrees later, we're at 270, and we're at infinity again. So an important thing to note is the the y-axis, or left-hand axis, y-axis of the tangent graph is gradient. And I would bet you a lot of money that if you ask people in your class what is on that gradient, what is on that axis, pretty much nobody in your class would say gradient. I've heard a lot of things in my time, but I'm pretty sure that no one would say that. Maybe ask the question, see what they say. Next thing, after gradient, tangent, we looked at sine. So in this case we saw that there's a thing going around the circle, and all we did as it went around that circle just tracked the height compared to the angle it made. So let's say 30 degrees, the height of it is there. When we did that, so 0, 0, 30, 30, it generated a sine curve, and then because we're tracking the height as that thing's going round, sine gives you height. Sine equals height. Okay? And again, I'm pretty sure you've probably never heard that before, but it's very useful to think of sine in those terms. It just gives you the height. That is only when the radius of the circle is 1. Okay, so that's why the maximum height on sine is 1. It's a normalised measure, it's always comparison to 1. Okay, so that's why sine of an angle is always less than 1 apart from 90. It's because the maximum it can be is 1. So it's another conversion from angle to height system. So if I know the angle, I can find the height. Or if I know the height, I can find the angle. The calculator does that. Incidentally, I forgot to mention that for tangent, same thing. So if I know the angle, I can find the gradient. Or if I know the gradient, I can find the angle and do the reverse. And they are inverse functions to find the reverse. Okay. And remember, I turned the page around, flipped it, and showed you what it looks like as the inverse. And you can do that in the exam, I don't mind. Okay, so sine is height. So then I said to you, last thing, what is cosine? So what did you come up with? I'll be interested to know. It's because sine and cosine are the opposite. I think you probably sort of intuitively know that. Then the opposite of height is what you said, length. I said length of what? And you didn't give me an answer. Because you were right, but I just wanted to be a bit clearer. And the answer is the width, is what I call it, the width. Because as this thing goes around the circle, it creates a triangle with this height, but also with this width. And as it keeps going around, what happens is the width gets less and less. The height gets more and more, the width gets less and less. The width's going that way. So up there, the width, again, smaller and smaller. And if we were to plot that, we'd have 0 degrees at the start of the process, the width is at a maximum, and as it goes around that circle, the width is decreasing. So 0 to 90 is going to look like that. And then on the way around, it just does the reverse thing. The width is 0, and a bit bigger, then a bit bigger, then a bit bigger to 1, so it goes down to there. Okay, and of course it's going to generate a cosine curve. So let me just rotate that 90 degrees so you can see it. Oh, my computer's giving up on me, just bear with me. So it starts up here at 1, maximum width. As it gets around to 90, the width is nothing. 180 is -1. And then just the opposite thing, which is why cosine curve is symmetrical. So cos is width. Okay. And with those ideas, we can then look at much more. It explains quite a few things. I won't go into it now, but I want to do it with you. But maybe you can think about it yourself. If sine is height and cosine is width, what does that imply for other things? Okay, so hopefully you found that useful. You did well. I mean, you concentrated well for 2 hours. That's good. I said to your mum as I was leaving that you have got a kind of mathematical mindset. The questions you ask, the way you think ahead, that's great. So it's very promising. So hopefully we'll keep going that way, and I'll speak to you in a couple of weeks. In the meantime, if you have any questions, please email me, make use of me, okay? I'm here to help you, alright?